So let's recap the equation of a circle. Now, x squared plus y squared equals r squared is an equation of a circle whose center is at the origin, 0, 0, and has a radius of r. So here are some examples where x squared plus y squared equals 25. Center is going to be at 0, 0. The radius of the circle is going to be square root of 25, which happens to be 5. Here's another example where center is at 0, 0, and the radius is going to be square root of 12. So now let's take a look at the equation of a circle whose center is at a point h, comma k, whose radius is r. So this equation tells us that the center is at some coordinate h, comma k. Notice the equation has the negative value in there, and r represents the radius. So if we have an equation, x minus 2 squared plus y minus 1 squared equals 4, the center is going to be positive 2, comma 1. They're both positive. The radius is going to be square root of this number here, which is 2. Now let's do it backwards. What about if I have the center is at negative 3, negative 2, and the radius is 3? What would be our equation? Now, since the coordinates are both negative, when we plug it back into the equation, the negative becomes a positive. So these are going to be positive in the equation because the coordinates are negative. And then the radius is 3, so you square it, and which is going to give us 9. What about if the center is at 5, comma negative 3, and the radius is square root of 21? Now, since the x coordinate is positive and the y coordinate is negative, when you go back, plug it into the equation, it's just going to switch. So it's going to be x minus 5 squared plus y plus 3 squared. And since the radius is in radical form, when you plug it back in, you square it. So it's just going to be equal to 21. Okay, so that's a recap of equation of circle. So how do we graph the equation of a circle? Now, first, you're going to just look at the equation and identify the center and the radius. So the center here, since this is plus 4, you know that the coordinate, x coordinate is going to be negative 4, and here's the y coordinate is going to be positive 3. And the radius of the circle is going to be square root of 16, so you know that's going to be 4. Now you're going to plot the center, which is at negative 4, 3, which is going to be in the second quadrant. So you put the coordinate of the center first, and then since the radius is 4 units on the coordinate axis, it's best to count horizontally and vertically 4 units. So there's going to be 4 units this way, above, left, and bottom, and then put the points there, and then just draw a nice circle that will go through those 4 points. So that's how we graph the equation of a circle. Now, so now that we have the equation of a circle, we have something called the general form. Now I'm going to derive the general form from center radius form. This is called center radius form because you can easily identify the center and the radius from its equation. Now we're going to derive this in the general form. Now to do that, we're going to just expand this, multiply everything out. So x plus 4 squared means you have 2 of these, so you're going to expand it out. And then you're going to have y minus 3 squared, you're going to expand it out, and you're going to multiply it out. So when you multiply these two binomials, you're going to get a trinomial. If you do the distributive property, then you get x squared plus 8x plus 16. Here you're going to get y squared minus 6y plus 9 equals 16. Okay, so we just distributed and got this expansion. And when you expand it, let's see if we can combine like terms. If we rearrange it to the highest degree to lowest degree, it's just going to look like this. So I put x squared, I put the y squared right after it, I put the 8x after that, and then the y term, negative 6y, and then we combine the 16, 9, and the 16 here. So notice the 16 disappears, so we're left with the 9, and that's going to be equal to 0. So if we set it equal to 0, this is actually the general form of a circle. So general form looks like x squared plus y squared plus cx plus dy plus some constant e equals 0. So the general form of a circle looks like this. Now, what if I gave you, or what if there is an equation in general form? How are we going to change it so that it's in center radius form? So let's take a look. So here's an example. So notice it's x squared plus y squared. We have an x term, a y term, and a constant term. So we want this to look like center radius form, so we can easily identify the center of the circle and the radius of a circle. So the first step is the technique that we need to use is complete the square. So to do that, we're going to rearrange it where we're going to combine the x terms and the y terms and kind of rearrange it so that we can complete the squares of each x term and the y term. So now if you take a look, I put x squared minus 4x, and I left some space here, and I put the y squared minus 6y, and I left some space here, and I brought this constant over to the right, which means I subtracted a to both sides and got this. Okay, so this is the same equation. Now since it's an equation, whatever we do to the left, we're going to do it to the right. Let's focus right over here. Now we have x squared minus 4x. We want to complete this square. Okay, so when we practice completing the square, how do we complete this square? Well, we take the middle term, the coefficient of the x term, divide that by 2 and square it. If we do that, we get negative 4, divide by 2, and if you square that, you're going to get positive 4 here. When you do complete the square for the y term here, you're going to do the same thing, negative 6, divide by 2, you get negative 3, you're going to square that, and you're going to get positive 9. So you're going to add 4 here, and you're going to add 9 here to complete the square. Now, since we added 4 here and added 9 here, we also have to add 4 and 9 on this side because we add the 4 and the 9 on the left side. Okay, so we are going to add 4 here, add 9 here, and we're also going to add 4 and 9 to both sides. So now since we completed this square, this is actually a perfect square that can be rewritten as a binomial squared. This gives us x minus 2 squared. This gives us y minus 3 squared. And when we combine all these constants, we're going to get 5. So notice we get this nice center radius form. Now the center of the circle would be 2, 3. And then the radius of the circle will be square root of 5. So that's how we convert general form of a circle to center radius form.